Example 10. Solve the following integral differential equation of a series RLC circuit. To solve this equation, we take the Laplace transform of every term. So we will start with Laplace transform of di dt plus 60 Laplace transform of I plus 800 Laplace transform of integral of 0 to t, and then it dt equal to Laplace transform of 20 of 1 minus u t minus 1. Okay, then we look at the Laplace transform of di dt, which is equal to here, we shall give you as Laplace transform of I now minus I at the point 0 carbon. So this will give you the first term then 60 Laplace transform of I plus 800 Laplace transform of integral, which is actually this formula, which will give you 1 over s and Laplace transform of I. Then on the right hand side, there are 20. Now, Laplace transform of 1 we know is 1 over s. And then Laplace transform of unit step function is actually this one. Is e power minus 1 s over s. Your c is 1 now. Your c is 1 now, so that's why got this one. Okay, then we put in the initial condition I0 equals 0. So this is equal to 0. And then we collect all the Laplace transform of I together. We will get s of Laplace transform of I plus 60 Laplace transform of I plus 800 over s Laplace transform of I, and is equal to 20 s times 1 minus e power minus s here. After we rearrange them, so that means that if I multiply both sides by s first, I get s squared plus 60s plus 800 Laplace transform of I is equal to 20 1 minus e power minus s. Continue from the previous page. So we know that Laplace transform of I is equal to 20 times 1 minus e power minus s over s squared plus 60 s plus 800. Now, you see we can factorize. We find that this is equal to 20 times 1 minus e power minus s, and in order to factorize, you need to 40 and 20 here, so we get s plus 20 s plus 40 okay. Then you can find that, okay, how to find I here. We need to do partial fraction here. So let's take out 1 minus e ix first. Okay, 1 minus e minus s here. Then here 20 over s plus 20, s plus 40. Then you do a partial fraction. This is actually 1 minus e minus s. So this will be s plus 20, s plus 40. Using cover up method. So you cover up s plus 20. Then you have okay, let's call this number A. Let's call this number B here. So A is equal to 20 over s plus 20, s plus 40. I cover up s plus 20 and then put s equal to minus 20 now. So we get 20 over 20, we get 1. So A is equal to 1. To find B here, the 20 over s plus 20, s plus 40, cover up s plus 40, and put s equal to minus 40 now. So you get 20 over minus 20, you get minus 1. So A is equal to 1 eventually, and B is equal to 1, minus 1. Okay, so I'm going to find out what is I now. Therefore, I is the inverse Laplace transform of 1 over s plus 20 minus 1 over s plus 40 and minus inverse Laplace transform of e minus s over s plus 40 minus e power minus s plus 4t. Okay, then the first term is equal to e power minus 20t, then minus e power minus 40t. By looking at the inverse Laplace transform, and then the second one, okay, we are going to use the formula here. Second shift theorem. Your C is equal to 1, and then your Ft, okay, let's see for here, the C is equal to 1 here. Okay, the Laplace transform of Ft is, for example, the first one is Laplace transform of Ft is actually 1 over s plus 20. Okay, so you can see that I just want to make sure that you see the picture here. So this one is actually here, and this one Laplace transform Ft is actually here. So that means Ft for the first one is actually e power minus 20t. So I should get the answer for the first one is u of t minus 1, since c is equal to 1 now, and then ft minus 1, so fs is 20 e power minus 20t here, so ft minus 1 is e power minus 20 t minus 1. Right? So ft minus 1 is actually e power minus 20 t minus 1 for the first term. The second term, also similarly, you have u t minus 1 now, e power minus 40 t minus 1. So then you combine together, you get equal to I equal to e power minus 40t here plus e power minus 20t, then minus, take out common factor, you have e power +40, okay, plus here, e power 40 minus 40t minus 1 minus e power minus 20 t minus 1 times u t minus 1. That's the final answer for example 10. So answer for example 10 is this one. Okay, the working of using second shift, the detail of using second shift is actually here.